Good afternoon for everyone. It's after 5 p.m. and we can start our today's railway talk. My name is Jacek and I have a honor to leading today's 10th railway talk on track maintenance. Professionally, I am involved in railway infrastructure, specializing in tracks and turnouts, and also in parallel, I'm a president of the Association of Communication Engineers and Technicians in Poland. The main topic of today's presentation is track maintenance. The speakers works in companies specializing in the rail traffic analysis and the construction of machines and equipment to quickly and efficiently restore track to serviceability. A major significant influence on the need for development of track maintenance technology is the continuous increase in demand for transport with the lowest environmental impact, as rail is known as the most ecological transport. For this reason, the trend is to build new railway lines and shorter the maintenance processes of the track, so that long track closure should be eliminated. Currently, most European Union countries are focusing on automation, also due to the lack of workers and their skills. The fourth industrial revolution is also coming to the rail industry with the introduction of intelligent machines and systems and increasing the efficiency and flexibility of production processes. The railway is digital now, and both Plasser and Theurer company and Robel rail automation company showed in the description of their presentation that high quality maintenance combined with end-to-end solution reduce cost and additional work. Therefore, kindly ask for the first presentation for Mr. Dr. Fabian Hansmann from Plasser Theurer company. The topic of presentation is Utilising automation in track maintenance.
My name is Fabian Hansmann. I'm with Plasser and Theurer since now almost 10 years. Originally, I studied civil engineering at Graz University of Technology, did my PhD thesis there in railroad engineering, and I'm working now here as head of marketing. Well, thank you for the invitation to this railway talk. It's really a big pleasure to talk today a little bit about automation in track maintenance and how we think that automation in track maintenance will help us to tackle existing but also future challenges. When we look back, we can see that actually track maintenance has changed quite a bit in the last decade, so to say. So the way how we maintain track changed more or less moving with the increasing requirements of the railway system. So when we think of the hard manual work at the beginning of the last century, the first mechanical mechanization, the first mechanical tamping machines, the introduction of the assembly line method, all aiming more or less to increase the efficiency of the system, the precision, and the increase or to increase the performance of the track maintenance machines. In the last years or decades, we were able to see also the trend to more environmentally friendly systems. And also we can see that in the last years, we see a lot of digitalization going on, a lot of connecting, a lot of AI introducing or changing the way how we maintain actually our tracks. So what we can see is that the way how we maintain our tracks actually involved with the requirements to the railroad system. So what we can see is that we currently have an increasing challenge with the lack of skilled people. And this is not really an isolated problem, what we can see so far. So this is not a problem that is isolated to one single country. This is a problem that we have as a whole railway industry, not only focused on railways, but also as for us as manufacturing companies, also for planning companies. We can see that the lack of skilled people will have a tremendous impact on the way how we maintain, how we operate railway tracks. This is an example from England, where we can see that only 5% of the workforce will be under 25. the German Federal Railways identified the lack of skilled people as one of the core risks for the business. And the APTA, so the Association for Public Transits in the United States, goes even a step further and says that the shortage of skilled people already has a significant effect on their services. So the lack of skilled people is already a big issue as a standalone problem and will raise the challenges that we have. But this issue combined with increasing demand for more capacity on the existing infrastructure, so running more trains on existing infrastructure, really is a terrible combination because we want more trains running with less people. And this really opens the doors for introducing digitalization into the system. This is nothing new for the system. That is what I have to say. The railway system has used digital tools from the beginning on, like for signaling or also for controlling and monitoring maintenance of way equipment. But it is a challenge. Like, for instance, the Austrian Federal Railway clearly says that they want to double their capacity until 2040. So we have to run more trains on the existing infrastructure with less people. And that is exactly where we see a potential for maintenance of way equipment to support or help the system achieving this goal. And of course, if we now want to talk about, okay, how we can automate track maintenance, everybody would assume we have to talk about big yellow machines. But we want to do a different approach here because one thing is clear, you can only get high performance out of a high performance machine if a lot of different aspects are working together. So we have to switch here a little bit to an end-to-end process when it comes to track maintenance. So not only focusing on the track maintenance machine, but focusing on a process that combines pre-measurement, the work preparation, the execution, and the documentation. And that is a really important aspect here. Giving you an example, a high-performance stamping machines will not work with high performance or will not be able to achieve high performance results, high quality, if the stamping machine does not have the surveying information, so that the information from a pre-measurement run. A high-performance stamping machine cannot achieve the high performance if there is not sufficient ballast loaded or located or stored in the position where we have to maintain the track. And what I wanted to say here is that when we talk about track construction, if we talk about track maintenance, it's not only about the big yellow machines. There are so many different aspects that we have to consider, and we can only optimize the efficiency of track maintenance if we optimize the process itself. So let us start with the pre-measurement. And the pre-measurement, when we talk about pre-measurement, we talk about condition monitoring. And that is nothing really new for railways all over the world. They are using measurement signals or measurement devices on measurement platforms or recording cars like here, the EM100 VD. It's all about finding the right action at the right time. But sometimes we measure and then we compare the measurement signals with thresholds, identify potential actions, and then we store the measurement signals in big data graveyards. And there the data are stored and nobody is looking at them again. So the question is, how can we do actually, or how can we make the data smarter? How can we use the existing information in a better way to get more information out of it? And that is really crucial because usually we are using recording cars, and recording cars are detecting or measuring different signals. We store them, we observe them, we analyze them. But the issue is, if we have the lack of skilled people, we have to get a step further. So we have to actually use the same recording car, analyze the data, but analyze the data is not the last step. We have to create information out of the data. So making information smarter means for me transform data into information and then information into knowledge. And that is exactly what we need when we consider that we have a lack of skilled people. Because only if we can create maintenance actions directly out of the data, it will make the planning easier, also for less experienced operators. And then in the final step, we have to connect the different information providers with the executors, like connect the recording cars with the tamping machines, with the bells, plows, with the regulators, so to say. So the future of track maintenance, the future of free measurement is not only to transform more or less data into information and information into knowledge. It's also about sharing this knowledge with the different stakeholders of the system, with the tamping machine operators directly, not with a flash drive, not with a USB stick. It's more about connecting different machines to each other to optimize the interaction between the different maintenance of way equipment. So once we have now identified the location where we want to do some maintenance action, we have to work on the work preparation. So we have now to do unload ballast, to identify, okay, what components are worn out, what I have to do. Well, how we do that currently? We'll still walk tracks some from time to time to identify, okay, what should we do? This is not an old picture. This is a picture of in the last couple of years, where a couple of different experts are walking the track, identifying in front or in advance for renewal action. Okay, what is the status of the drainage here? Are there any cables that I have to consider? And the question is, can we use the different informations of the different measurement signals by combining them, connecting them, creating a digital twin? And the answer is yes, we can. And I want to give you here an example from Germany where we had a renewal project between Hanover and Würzburg over 523 track kilometers. And there's this regulation that we have to walk the track, or at least we have to analyze the track condition before a renewal action. So in that specific case, walking the track would last almost 60 days. This is absolutely impossible in a time where we have a lack of skilled people, but also a lack of capacity, where we want to increase capacity, to put it in a different way. So we can, of course, use a digital twin. And that is what exactly we did in combination or in collaboration with our project partners here. And we were able to reduce the 60 days of track inspection down to 10% of the track possession, running a modern recording car over the track, combining all the different measurement signals into a so-called digital twin, which is now able to be analyzed in the office in a much more and friendlier or work-friendlier environment, but also in a safer working environment. And that is the second very important aspect here. We can run a recording car with 120 or 100 kilometers per hour, combine the information, and then analyze it in the office, where we can also work with experts, but also with probably not so much experienced operators. So once we have now identified where we want to do a work execution, we have identified, okay, how we want to do it, what do I need to do? Now is the question, okay, we have to execute now the work. And I want to show here an example how such a work execution can probably work in a more optimized way. And I have identified here, or I want to give you here an example for really system critical components like a crossing. A crossing is really critical for a railway. It's not only about changing from one line to another, but any failure in a crossing would have a drastic impact on the whole system. So the question is now, looking on such a universal tamping machine, can we actually support that machine, or can we train a track maintenance machine so the track maintenance machine is doing the work on its own, question mark, or at least monitored by not 3 operators anymore, but just 1 operator. So that was actually the goal of a research project we started 10 years ago almost, where we were looking into, okay, how we can start a journey towards a fully automated tamping machine. The main goal was actually to reduce the head count on the machine and tackling really the challenge that sometimes already we don't have the required crews to operate tamping machines. So it's not so about the lack of tamping machines in the market, it's more a lack of the operators to actually operate them in a proper way. So we started a research project that was more or less split into 3 different parts. The tamping assistant, which is actually the tool that operates the tamping machine or supports the operators by with supporting the tamping with operating the tamping machine. The tamping report, which is the documentation of the work, and the tamping control. What is obviously a little, very often a little bit underrated is that the operators on such tamping machines have to do a lot of adjustments. They have to actually put their tamping tools or their working tools in the right position to achieve a right or correct, to achieve high quality. But they also have to adjust like the lifting values. They have to adjust the damping depth, squeezing times. So running such a machine is not really easy, especially for beginners in the industry. So the main goal was, okay, how can we actually help beginners, unexperienced operators with running or with operating such a machine, but also how can we actually reduce the head count on such machines? So we are using more or less the tools that we also have seen in during the creation of the digital twin during the pre-measurement runs to record the data. We more or less built a digital twin on the tamping machine. We process the data, and based on like the identification of what are the different components, so on the segmentation of the data, we identify or we recommend certain actions to the operators. So how it works, it's pretty, oops, sorry. Yeah, here we go. So we in front of the machine, we have different measurement devices that actually scans and records the track sections that should be tamped. After the scanning, the onboard computer actually classifies the obstacles. The computer does that on its own based on the up to 6-month learning curve. So the computer segments the different pictures, identifies, okay, this is a tie or this is a sleeper, this is a cable, and so on. So it identifies the different components that usually appears during a turnout. And based on the classification of the different obstacles, the computer automatically calculates the configuration of the different working tools. So it identifies the obstacles, it identifies the ballast pad, it identifies different components, and then it calculates based on that and existing tamping plans, so more or less regulation, how a turnout should be tamped. It clearly gives a proposal to the operator and automatically positions the different working units. So the assistance system identifies the obstacles and then positions the different working units completely automatically on its own. After the operator has just to confirm or adjust depending a little bit on the situation. And then the working machine automatically executes the different actions, based more or less on the confirmation by the operator. This is still necessary simply based on the regulations of the current railroads. And then in the end, we automatically record the work quality and do the work documentation. So we have now moved from the pre-measurement to the work preparation to the execution. And now we come to the documentation, which is also very important for showing, okay, what have we actually done? And that is just one slide. It's a PDF document that the operator can actually give the railway, the railways, clearly showing, okay, how have I attempted to switch? Where have I actually inserted my tools? And this is just one slide. It also combines the different information from all different sensors. It gives you information regarding the ballast condition. It gives you information about the lifting wellness. It gives you information for each sleeper. How have you tempted? What quality have you achieved? So it really offers you more or less a transparent documentation of what work have you done so far. And now you can actually combine all the different tools into one tamping machine. So you can, of course, if you do that, you can only measure, for instance, track geometry. So you cannot cover the full range of a mesh recording car, but aiming on a track geometry, you can cover almost everything regarding the track geometry pre-measurement, even on a geotechnic surveying level, from the pre-measurement to the documentation, and also the execution for sure. So what is really important, what we want you to take away from this presentation, when we talk about challenges, when we talk about higher efficiency in the railway industry, we should not only look on one single machine. We should not only look on one single segment in this end-to-end process. We do not automate only one part of the process. We enhance every movement along the way, because only if each part of the process fits together, we can increase the efficiency of track maintenance. With that being said, I will come to the end of my presentation. I would try to show a video, but based on the connection issues that we had, I would just try to show it. Michael, Bobby, you can give me feedback if it runs well. If not, I will stop it and hand over back to the chair. Let me see if it starts in a proper way. Is it working, Michael?
It's a bit. Let's wait a second. Oh, it's stopping.
It's stopping. Okay.
Yeah.
So I skip it because I have explained almost everything already in the presentation. It would be just a nice video just showing everybody that this is not just an idea. It's a little bit more than an idea. It's reality already. With that being said, I give back to the chair. Thank you.
Thank you, Fabian. Thank you very much for the interesting presentation. Discussion panel is scheduled after the second presentation, and after that, of course, we can talk about your proposal, your point of view. But as you rightly notice, lack of skilled people and of course lack of workers makes to look for new solution, yes, new technical solution, digital solution, something like this. Yes, we're back to discussion after second presentation, and now, yes, please. Please, Michael, yes, I give you the voice, the Michael Reiter, Robel automation. The topic of presentation is automated robot supported ray and switch maintenance. Michael, the floor is yours.
So for everybody, my name is Michael Reiter. I'm really pleased to be here today and share about automation and all what we have done in the last years. I'm with Robel Rail Automation since now a little bit more than 4 years. I'm very excited to share the latest news on the topics. Perfect. So a quick question, presentation is there, can be seen, I think, by everybody. Welcome again from my side also. I think Fabian did a perfect job and prepared the ground to talk about automation nicely. It's a really holistic thing. And what struck me in that presentation, and what you will find again in my presentation here, is that the evidence-based automation, really focusing on the quality of work, is something that we really follow. And yeah, also the other one, the critical components in the infrastructure was mentioned today with the crossing or switches. And this is also something that I will tackle on. My presentation will also focus a bit on the technical side. So if there are welders on the presentation, they will see also some welding experiments. So it will be also a bit of a technical session here as well. Okay, let's start it. If it's moving here. So again, also one slide from the feedback that we received so far from our customers and partners. Why are they so interested in having a reliable transport and getting more trains on track? It's really that they need the help of robotization and automized solutions at the end of the day because of the lack of people. And with these solutions, we can contribute to the decreasing dependencies of the demographic change. That is really one core topic of all what we are doing and what is driving us. Another one that is very important to us is the short maintenance windows that we see and see everywhere. It was 8 hours, it is 4 hours, and as there is the density of traffic increasing, we will see more urban texts like 2 hours maintenance windows where the job has to be done. And this is already the physical border of physical work that can be done and can be achieved in the right quality in 2 hours. Another one also mentioned today already was improving the safety of people out on track. So reducing put in the ballast is one paradigm that we'd really like to follow. And also to have a repeatable work done, specifically if it's coming to welding, we want to really have this consistent, repeatable process there. And yes, sure, I think it's not even worth to mention, but reducing emissions on all sides is demanded by regulations, by laws, and we have to come up with smart solutions that allows us to work reliable on emission-reduced systems. And last but not least, it was mentioned also today that digital integration is key. So if automation goes hand in hand with the digital integration, then I think the value is there. So we know what to do, we have the evidence, we do the job, we document it, and at the end of the day, it's also a digital twin of the work that we do, not only the track, but also the work. And I think that adds value again for all the users. And if it's shared smartly between the infrastructure provider, the construction companies, and the industry, that knowledge will be the benefit of all passengers and all goods transported. Okay, so let's focus a bit more on the technical side. Today, I want to talk about two things that we actually automate. The one is the repair of local defects on rail, and the other one is the maintenance of switches. And this goes in a sequence, I have to say. 3 years ago on the IAF, we first introduced the local defect repair robotized and fully automated. And the feedback we received is, hey, guys, that's nice, but the most critical infrastructure component is the switch. So if you can do the switch, that would be a big benefit. And I want to talk about the two things that we have done here. If we are talking about automation, also on the tamping unit that we have seen from Fabian tackled that point, it's always considered as the end-to-end process. So our vision is with the press of a button, the machine on the right position on track performs the full job. And there is no interaction, no control mechanism from an operator needed. It's more observing and really helping with the operational and the logistic with the machine, but not infringing with the process because this is carried out automatically, always in the same way. Therefore, 4 years ago, we have built a technology carrier. We named it in these days, and it turned out that now it's much more than just a technology carrier. It's right now a machine that is used to drive homologation effects on the rail infrastructure, and is really used and applied to provide the first services. But I come to that a bit later. In total, concept that we are focusing is really to have a machine that enables us to focus on the process development, so to have a really stable maintenance process. and we neglect a bit the machine itself. So therefore, we decided to just use what's there, a flat wagon, put containers on top of it, fill the containers with stuff. One is filled up with the automation aspect, with the robots. The other one is filled with the energy supply and also an operator workspace. And then we have a robot frame that is carried out and does the job and performs the work. So a very simple aspect. Maybe I have to share this thought again. As we are a relatively small company, we have to focus on the core. We just have to do what adds value to our customers. And this is why we are not focusing on the machine too much, but on the real world processes that does the maintenance job, and also the software and the digital integration. This is our core. We're not inventing stuff, we're reusing stuff. And this is why we have decided to go with robots. This is, I have to say, in these days, one of the most proven technologies that you can find. It's applied 20 years in the car industry. They are running the full year, full hours a day. And therefore, this is really a technology with less maintenance and is that reliable and flexible to the work. It was just a perfect platform for us to integrate all the maintenance jobs that have to be done. Okay, so let's start with the local defect repair. What you can see here is last year in the Netherlands, we were out there on tied with a locomotive, and we're working on a heavily driven C7 track from the Rotterdam Haber to the German border. And our focus was to repair squats, pelrospies, and impressions. First of all, we did all the trials in our facilities in Freilassing. And as they were approved by the DEKRA, we moved out with the system to the infrastructure and did the homologation work there. The end-to-end process in this case was carried out on our R260MN material. So it meant to us we had to preheat the material. And so from measuring the geometry, milling the material out, welding it up, reprofile it, and support all the processes with measurement was the core process that we have carried out there. Insight that was also tackled by Fabian a bit is really what we heard from ProRail as infrastructure provider. And I said in 2024, if they look into the availability of stuff, a certain fraction of ultrasonic defects can be done. And these are the critical ones with immediate actions and some maintenance work. But the category 4, that is preventive maintenance, is already not possible with the available stuff today. And as they see the rise in traffic by 30% in the upcoming years, also the work and the defects will increase. And we can assume that the availability of stuff will not grow. It will rather deteriorate a bit. And that makes up a big gap that we have to close with machines at the end of the day. And I think all the people here in the room, they see it. Machines, they did a great job in the last 30, 40, 50 years in helping people to perform the jobs. And this is exactly what we do on the welding and on the repair of rail and switches. It's exactly the same. Here are some impressions of what we have done in the Netherlands. I hope now that the video, oh no, I will skip it as well. You can see the preheating step here. So we are using ceramic plates built on the robot, bringing it down to the rail, heated up to 350 degrees Celsius, ideally prepared for the welding process. We weld it up layer by layer. So the homologation in the Netherlands and from a European standard point of view, there are clear rules that you have to hold, intermediate layer temperatures that have to be fulfilled. And we have built then 8 welds there in the infrastructure on this heavily driven track. And they are observed every month by an independent DEKRA employee. And they are checked. In parallel, for sure, before we went there, we checked it also from the material consistency, the hardness, and all that stuff. And that works out since then nicely. So all the welds that were prepared in the Netherlands infrastructure on the railheads are there. They are working, and there are no defects, neither recognizable with ultrasonic or with color testing, nor with visual inspection. So again, coming back to the feedback on the AIF, yes, the rail is a nice thing, but what is really important is to deal with switch frogs. And here I want to mention two grades of material. One class of material that is based on the manganese material needs a very cool treatment process, whereas switch frogs made from HT350 material, they need a high energy welding process. So two completely different welding processes on two completely different materials. And we have found a way to deal with both with the same equipment, just with two different processes and two welding materials. And this is what I want to share here in the upcoming slides. So the problem that we really like to solve is worn switch frogs. As soon as you get wear on the switch frog, the dynamic forces are increasing, and that even hurts every wheel that drives over this already a bit damaged switch frog, hurts again, and it leads to shelling, to wear and breakouts. And these are the defects that we are prepared to maintain on the two materials as mentioned. Before we go into the welding process, let's have a look on the life cycle of a switch that is installed. And it all starts with the data from our perspective. It is the data pool is the decision criteria, the golden book where you derive your actions. And it starts already with the design and the manufacturing in the fab. So from our perspective, the lifecycle management has to be supported best already with this information that comes from the manufacturer of the switch frog. So the geometrical information should be there. Then the switch frog gets installed, the initial treatment is done, and I look to the left corner of that slide here. If I look to the system of a switch, the ballast, the sleepers, the fastening, the track plays all a role. So in the ideal world, we have a look on the system itself, so the ballast and the ties are in the right position to have a good integration of a substitute with a switch frog. And then as it is installed, the preventive maintenance starts. So grinding or a retamping step keeps the switch frog in the right position, in the best position to keep the dynamics on the switch frog as low as possible. And let's do this as often as possible, because that helps us to keep the life cycle of a switch frog long. And yes, there will be the point in time where plant maintenance or repair has to happen because we're seeing breakouts and the material is a little bit already worn. So the maintenance step has to be there as well, carried out and planned. And last but not least, this is the thing that no machine can deal with, because the team is the best solution for it. It's still the welding team that does the unplanned maintenance. So if there is a red alert, a switch frog has a problem, it's the team that still goes there and fixes the problem so that the next hour the trains can run probably again. And last but not least, it's about the refurbishment of the switch frogs. So in terms of the how to say that, to reuse the material and to save CO2 and resources, it's also a way to refurbish switch frogs on site and to reinstall them. So this could close the full cycle of a life cycle of a switch. Yeah, the constructed and the wear wheel drop, I think I made already the point. So let's keep the constructed wheel drop as long as possible in the original shape and keep the wear on a low level using preventive maintenance, plant maintenance, and also the unplanned maintenance. So let's see a bit the technical background here again. milling in manganese material on a robot. 3 years ago, we heard loud and clear a lot of responses and saying that is not possible, it will not work. Manganese is a damn hard material, and on a robot that is not that stiff as a CNC machine, it will not work. Right now, we are in the position that on a manganese switch rock that you see here, we can mill a driving edge in 30 minutes in 2 centimeters depth with one milling tool. And so this is a bit of proudness I share here also with the team. It is really fantastic how that damn hard material can be milled. Then as a next step, we put it again, the switch rocks into the lab environment, into the fab, and started with the welding process. Here again, I have to mention it's a cold welding process. So we have to make sure that we stay under 250 degrees Celsius during the welding process and do this layer by layer. The slide here shows a bit of the magic, of the technical magic that we are applying. So maybe some of you have a good understanding of a 3D printer. It's the same what we are doing here. So we are cutting out the geometry, we measure it, so we know exactly the missing material, and that is then subtracted by an algorithm into layers, and these layers are built up with a welder. And this is simply what we're doing here, but it took us quite some investigation to come up with a stable process that works on all the different geometries. Then the weld is reprofiled. Currently, we are in the step to do it with the milling. And then as a next step, we also will do the reprofiling then with the finishing step with grinding. But this is still under investigation and development. But the milling is already implemented. Material analytics show really nice results. So hardness level is there. Also, no inclusions is in the material. It is through the first observation of an independent institute, and we're still working on the material, on the tests. Another story, besides the manganese material, R350 HT is the second grade of material on switches. And again, same as on the 260 MN material, it needs preheating. And here with ceramic plates, we see some limitations because we have to reach out to this geometry of a switch rock. And therefore, we decided to utilize a heating process, like you know it from in the kitchen. The inductive heating induces the temperature within the material. So, and it's extremely fast because we are able to convey the energy without losses and very fast. And the results that we have achieved here are really amazing. 250 degrees within 15 minutes. It's really a very fast time to get it through heated material. So the difference is not that just the surface is hot, it's really heated through the whole material, and that helps the welding process extremely. Here are some examples, 350 HT. So that is really a big cutout of a wing rail on the right-hand side, and the needle is welded up 2 centimeters deep and a length of 800 millimeters. And we can say that this needle, we have cut it already. The intersections of this needle looks pretty nice, and the hardness is there, and the material consistency is there. And yeah, this is on a really promising path forward. Same, the wing welding on the 350 HT. And that leads a bit into now the thought process. If we weld the needle and the wing, we have to achieve finally the right geometry for a low dynamic wheel transfer. And this is still the topic that we have to solve and to cover. At the end of the day, the perfect wheel transfer geometry has to be achieved. And therefore, again, it needs strong collaboration between infrastructure providers and construction companies and the industry, because it's not easy to name the ideal wheel transfer geometry. So we need to put our heads together and define it. Some more examples. This is more on the preventative maintenance side. So it's not 2 centimeters deep of mill-outs. It's just building up 1 or 2 welding layers to preventively maintain the switch frogs and just do a final finishing in grinding and have a good switch frog after the repair again. The digital integration, as mentioned, right now it is a sophisticated workplace. We are measuring all the vibrations. We are storing, by the way, all the vibrations, all the geometrical information, the video information during the treatment. And yes, it will shrink step by step by step. At the end of the day, there will be just 1 monitor with the press of a button, and the whole process is carried out. And all the information shown here is just background information that we can pull up again if it's needed, and it can be added to the life cycle history of a switch frog that was maintained. A last thing here to mention is also the machine itself and the processes and the location and the status. All of that is tracked, and it builds then the history of the digital twin of the track, but also of the maintenance process. Good. What's next? 3 things. Right now, and after the AIF even more, we are on the trip of homologation. So we have now several requests from infrastructure providers to come over with the machine and perform the homologation of the welding processes. And yeah, the challenge we see is really that on the one hand, we have already existing homologation results, and that we don't reinvent the wheel again, but maybe just a focus on the differences in the various different countries in terms of homologation, so that we don't have to do it all over again, but benefit and copy with pride what already exists. It's all a bit of a call. Maybe there is interested people here in the group as well and have some feedback on it, but it will really help to speed up to bring such a technology into the market. The second one I wanted to share is the local switch frog development, but also services that we provide. And last but not least, the next generation of machine. So the homologation, as mentioned, it started in the Netherlands and it's now moving out into other European countries. We're right now in the negotiation phases to get the next homologations out in the European infrastructure. And one of the recipes, one of the core success criteria, again, I have to say it over and over again, it's collaboration. So having construction companies sitting on the table, the infrastructure provider and the industry, and really trustful sharing what's needed and how the next steps can be done together is really the key to success. Nobody can win the race alone. We can just do this together. The in-house switch services, this is what we're starting up right now. So it's easy to imagine if you can do it on track, why not to do the switch maintenance also on site? And so we have built now a switch maintenance frog on site in Freilassing, and this is already now in the test phase to homologate the switch frog repair for manganese switch frogs right now, but we would be open also to do this for R350 HT material. And that is my last slide for today, because I also skipped the video that I have prepared here. The next generation of machine does consider 2 major aspects that we have learned over the last 3 years. With the current technology carrier and prototype we have in our hands, we are able to deal with an infrastructure length of 1.5 meter. And for specific switch frogs and also for other maintenance work besides welding, it is demanded to reach out a bit more in length. And therefore, we have decided to open up a 7-meter maintenance area to the track. And that changed the system a bit. So right now you can see here 2 flat wagons that are separated on the site construction. And the 2 robots that have now the capability to move over 7 meters of length. So the welding robot and also the handling robot, they are able to move over the maintenance area, and therefore we are able to cover 7 meters. And the second big aspect that we have implemented here is we are more modular than ever before. So the boxes that you can see on top here, these are boxes, tool boxes or spare part boxes, even robot boxes that can be changed on site and extend the functionality of the system. So the good message here is if we go for a first investment for a welding robot, as it is shown here, it is open for the future also to deal with other maintenance tasks just by substituting the toolboxes and the one or the other robot to perform additional tasks with the system. So in a nutshell, I think what the two presentations had in common was really that the evidence measurement-based a machine that does the work and helps the people to do more work and helps the infrastructure provider to have more trains running on track is really a target to utilize automation, and have that all documented and fully digital integrated is a great asset to improve the life cycle of the track. So thanks for your attention, and I give it back then to the chair.
Okay, Michael, thank you very much for your presentation. New technology related with the preventive and corrective, and like you mentioned, planet maintenance, which will be focusing on the improving parameters like the reliability, availability, and maintainability, and consequently reduce whole life cycle costs are very important for everyone, and requires constantly improving. Now I will try to open my camera and open the panel discussion. Yes, I'm here. Hello once again.
Yeah.
Have we got some questions to presenters? Maybe somebody want to share with their knowledge, experience in the track maintenance? Okay, gentlemen, but okay, maybe first question will go from my side. That's, I don't know, the Robel or Plasser company calculate the RAMs parameters, like the reliability, availability, and maintainability based of your new approach to the track maintenance. Somebody with the company and try to calculate the parameters about availability, how you improve the parameters of availability of track operation using for example, the modern approach of the modern machine to track maintenance.
So I think it's a very interesting question here, and I would try to answer it in this way. Besides the technology that we have introduced today, I think there is also the operational aspect of the machine. So how do you bring such a machine into the infrastructure in operations? How does the logistic process look to it, and so on and so forth? And the whole package, what does that mean in terms of improving the reliability of track? This is a discussion that we now are having with the infrastructure provider in the Netherlands, for instance. And I think we did not take a scientific approach here, but it is worth to look at it. So this is what I want to give here as a feedback. So very good comment and a good approach to use.
Mm-hmm. Jacek, it's probably an interesting question, and I know that you were looking for some percentages probably that I can give you, right? But some real numbers. But like for the assistant system really focus on delivering consistency, delivering the same quality, right? So like when we consider a concrete sleeper track, we can achieve tamping cycles or tamping intervals of up to 5 years, depending, of course, on traffic load and what kind, if you have undersleeper pads or not, and so on. But what we can see, the operators can really adjust a lot of parameters. And although the result might look the same at the beginning, over the 5 years, the deterioration of track geometry can change dramatically based on the adjustments the operator can take. So what we try is actually deliver the same results, the same quality with each tamping action.
Okay, thank you. Yeah, my question goes directly from the standard European standard related with the RAMS parameters. Yes, and now a lot of companies introduce calculation of these parameters. Yes, and maybe in the future the digitalization of railways helps us everyone. Yes, to collect the data and of course show the administration of railway. Yes, the facts. Yes, the data. Yes, not only imagination, yeah, but really important digits. Yes. Okay. Have we got some question? Okay, we have got the question. Yes. Please introduce yourself.
Yeah, hello. My name is Uwe Lauschke. I'm with Bertrand. I don't know. You know, Bertrand is a huge EDA engineering partner for many companies, industry companies, also in the railway business. So my question is actually, do you have a mass problem? Maybe not problem, but are you interested in making your machines lighter? Or are you saying the machine anyway is huge, is heavy, and you don't have a mass problem? I don't know. I have no feeling for this.
Well, I would not say that we have a mass problem. Yeah, that is what I would try to avoid to say that. But of course, so the axle load is it's a critical aspect for maintenance of way equipment, especially when we think of bigger machines like undercutters or so ballast cleaning machines. So we have strictly requirements regarding the axle load. For instance, we're also delivering machines to the Japanese high speed network where we really have to fulfill low axle loads. So delivering or offering lighter solutions is always a challenge that we have, but we also have to consider that we have to fulfill certain crash requirements or certain standards that really requires to use heavy metal or heavy material. And it's also like we have to lift turnouts with concrete sleepers. So that requires that we, on the other side of the tamping machine has to be also heavy. Otherwise we are not able to lift something that is heavier than the machine, right? That's a Münchhausen weight of doing thing, which will not work.
Yeah, understand. Thank you.
Okay, have we got more question?
I think we have one question in the chat. Adam is asking, what is the impact of weather conditions for the data processing?
Yeah, I know. Is it something like limitation during the running or snowing?
You mean for the stamping assistant? I'm an engineer, so I usually start the question with "it depends," right? So but not far aside. So normal weather conditions, the machine runs pretty well. So we haven't experienced any issues with the machine based on any weather conditions. I'm not saying that there are not, but currently we have tried the tamping assistant or implemented the tamping assistant on almost more than 10 machines in 4 different countries, also in the United States, where we have really rough conditions and we haven't experienced any issues regarding the weather.
But maybe I would try to develop the question about, for example, the monitoring and potential diagnostic of the track. Yes, it's also some connection with this weather condition or on.
Well, of course, there are some measurement devices that can be affected by weather conditions, like for instance GPRs or ground penetrating radar. Of course, if we have heavy rainfalls before you run a GPR over your track sections, that the results will be different. So there are some effects that you have to consider for sure. Yes.
Okay, and we have got the next question from Marco Meroni. How the smart stamping process consider also the outer geometry of the railway track means that geodetic position based on the reference network with the check of this reference network point stability. To don't just the track only based on chord
Okay, got it.
and inner geometry parameters.
This is okay. I will try to keep it short, Marco. If you want to have any additional information, you can always reach out to me. In general, you're right. So temping machines usually use a chord measurement system for the measurement of the working units, so for working. However, like new temping machines can also use an IMU for doing that, actually. So an inertial measurement unit, so not the chord measurement anymore. And of course, you can also equip temping machines with the reference track geometry system on the first bogey of the machine. With the reference track geometry system that we have developed, that is mainly based on a stereo camera system, you can actually reference the inner track geometry to the mast bolts, so the outer track geometry. And with doing that, you can actually doing a geodetic surveying. It is, to keep it short, right? It would take a little bit longer to explain everything in detail, but if you need more information, just let me know, and you can probably share your email address, and I will reach out to you.
Okay. And next question goes from the Vlad Metaxa, and one question for Mr. Reiter. Do you need to change the milling head after milling a manganese switch? I think in slide 22 you were talking about this.
Yeah. So give a quick answer to this one. Our target is to have a full manganese switch rock milling process with one tool, and the machine will have a tool changer. So even if we recognize that the parameters, the friction or the vibration on the milling head increases, then the system automatically exchanges the tool.
Okay. Okay. The question from Simon Eftimov. Sorry if I not clearly read. Does the digit integration bring track maintenance closer to the track users, or with other words, closer to the vertical integrated railway?
Yes.
A little confusion now. Yeah, I understand.
I don't know if I understand completely the direction you want to go with that question, right? But digitalization will actually hopefully reduce the amount of track maintenance that we have to do on the track. It will also help us to preventively plan track maintenance. That means also we can forecast actual interruption of the track, like in a long-term perspective. So you can actually plan track maintenance. You can inform your customers that you will have an interruption. So I think if that is what you mean, will digital integration bring track maintenance closer to the customers, to the track users? Then the answer will be yes, definitely.
Generally, I think that now we are during the fourth industrial revolution, yes, and digitalization is everywhere, also in railway business. Okay, the question from Andreas Holthaus to Mr. Hansmann. From your perspective, how is the topic of track digitalization currently perceived across Europe? Are there already established standards or norm among railway operators for digital track inspection? And are there certain infrastructure managers or countries that are clearly ahead in implementing these technologies? Okay, 3 questions in one.
Yeah.
Okay, let us start with the first. I think there's a strong push towards digitalization. So everybody's talking about it. I think it's getting one of these buzzwords. So everybody's talking about it. Implementation is where we struggle a little bit, and that's also limited by the standards, right? There are a lot of early adopters, so I don't want to highlight any specific railroads here because I think European railroads usually have really the approach to implement new technology because they really focus on the customers. They want to improve their systems. So it's really good, like working in partnerships. So we have some kind of early adopters, and it's really good for new technology to get into the system. What's limiting us here is the standards, to be honest, and the norms. And of course, there are norms, but they are developing, in my personal opinion, that's just my personal perception, they are developing too slow to keep the speed of the development that we currently see when it comes to digitalization.
But do you expect new requirements, new rules from governments that you should, I don't know, put some new documents related with digitalization of your product from the 2027? I heard that new regulation entrance on December 2026 related with the cyber security, and maybe will be also related with your products.
Yeah. So of course they are, like, especially when it comes to cybersecurity, data ownership, data integrity. So these are all really very, very important topic when it comes to digitalization. It's really, I think we are expecting there's something coming here, and of course the data protection has to be our #1 priority. That is also the reason why we try to keep all the data that, for instance, for the smart temper, so for the tamping assisted, it's an onboard and offline processing. So there is nothing going into the cloud except of the documentation that is then uploaded into the cloud, but more or less the calculation. So the data processing is an onboard calculation. So it's edge computing. So that helps us a little bit, right? However, we also have to fulfill certain requirements regarding reliability of the system and so on. So there are a lot of regulations that we have to fulfill. But sometimes, and that is the only thing I wanted to point out here, regulation is not helping us, right? A regulation can slow innovation, or it cannot. It does actually, right? So that is the big challenge that we have. And don't get me wrong, I understand that safety is our #1 priority, and we have to ensure that what we will implement in the track or in track maintenance has to be safe. However, we have to get certain possibilities to try out innovation, and that is why, and I think Michael also pointed it out, why partnerships are so important. And the European railroads are really open to partnerships. That is what I have to point out here.
Michael, you want to add something in this point?
No, I just was looking to the next two questions that were coming up here.
Yes, okay. Question to Michael. Yes, what is the time estimation from threading the turnout manganese frog?
Yeah, exactly. So right now we are for 2 wings and 1 needle in a length of 30 centimeters and in a depth of 2 centimeters. We are below 3 hours for the pure treatment process, and we need approximately 45 minutes for the logistics. So this is the experience. The logistic is really the one that depends on the site, how you bring the machine into the construction site. But the pure working process is below 3 hours on the manganese wheat frog. And the second one, I think, is more targeting to a local defect on a rail. And therefore, what we have done is 3 repairs in 6 hours. And that was big norm and standard conform repairs. So if there are smaller, we can even do 4 or 5 a shift.
Okay, this question will go from the Adam Konkiel. And the next one is from the Hespers. And could you, okay, maybe you answer on the both you want sentences, but both?
Yeah.
Okay.
Yes. And anyway, so I also make it the same as Fabian. If there is more technical questions that we cannot cover right now, please go into contact, phone us up, or shoot us an email. We are really happy to get in contact with you and answer the questions.
Okay, I think that your email address will be available. Okay, Michael, impressive. Madam, respect.
Thank you.
Charlotte confirmed that your email will be available from the all. Yeah, Charlotte, we can see you at the moment also. Oh, okay. Any question?
Yes, hello. Also, thank you very much from my side for the great engagement and then many questions. I hope you can hear me now. I had some troubles in the beginning to log on. So, Jacek, if you want to say a couple of words to finish off, and before that, I want to invite everybody. Please remember, I think you have seen it in our many emails. I'm sorry for we sent so many emails reminding you, but about the Rebel Talks. But we will have another conference coming up in November, which is the Railway Forum, to be held in Napoli, in Italy, and we really invite you, everybody, to join us. So Jacek, please.
Yeah, yes. From my side, of course, I would like to talk that. Thank you very much for the presenters, for their excellent presentation and comments. It's not easy, especially on the maintenance of the rail surface. And thank you very much. Also, it was important for me. I feel that I'm something like expert on railway turnouts in Poland. The new technology, what you show in presentation, was very interesting, and of course, develop also myself in the future. And okay, thank you very much for all participants of our 10th Railway Talk. Please check out our new Railway Talk proposal. And of course, if anyone would like to share their experience, please email to Charlotte. And Charlotte, of course, thank you very much also for you. And see you soon for everyone. Bye-bye.